tales of mechanical beings date back to ancient times. For instance, the myth of Talos depicts a colossal bronze man built by Hephaestus, the Greek god of invention and blacksmithing. Tasked with safeguarding Crete, this bronze figure patrolled the island 3 times a day, hurling boulders at enemy ships nearing the coast. In the medieval European and Islamic world, devices like Al-Jazari's automata, including water clocks and programmable machines, showcased early engineering prowess. One of the greatest pioneers of the Italian Renaissance, Leonardo da Vinci, sketched designs of a mechanical knight capable of limited movements, foreshadowing today's humanoid robots, and a mechanical lion. So, the idea of robots and the robotics field is not new. People have been fascinated with them for a long time. It's a true phenomenon in pop culture that has captured the imagination of previous generations. So, what's different today? Rapid technological advancements, and mainly the incredible growth of AI, are making possible the creation of intelligent machines, which we could only imagine and depict in movies in the past. Robotics is the branch of technology that deals with the design, construction, operation, and use of robots. Machines that can perform tasks automatically or with human-like capabilities. Let's break this down. Mechanical engineers are needed to construct robots' physical structures. They are responsible for designing and constructing robots, including their mobility mechanisms. Electronics and electrical engineers design systems that enable the robot to operate and control its actions. While electronics power the system, various types of AI drive the robot's decision-making and behavior. Robots are equipped with various sensors and cameras to collect necessary data and perceive their surroundings. This is how AI developers and engineers pitch in. So, this truly interdisciplinary field requires specialized skills in several distinct areas. Like other types of AI, the robotics domain is inspired by human capabilities. Robots are designed to mimic and augment human abilities. To achieve that, researchers use a multidisciplinary approach combining different AI technologies. Typically, we should consider a system with multiple models instead of a single model that does it all. For example, an autonomous robot might use computer vision for object detection and environment understanding, simultaneous localization and mapping for navigation and mapping, reinforcement learning for decision-making, and a natural language processing model for understanding and generating human language. Combining all these models allows a robot to perceive the environment, make decisions, communicate with people, and act accordingly. Let's point out several intriguing use cases. You probably know that under the direction of Elon Musk, Tesla is building a Tesla bot, which is described as a general-purpose robotic humanoid. The goal is to create a robot that can relieve humans of dangerous, repetitive, and boring tasks in logistics. For example, a Tesla bot could help with factory and warehouse work, moving and stacking boxes, counting and auditing inventory, and lifting weights. And it's not just Tesla. Many companies develop their own autonomous robots and contribute with valuable research. Medical robots are a fascinating use case already in the mass adoption phase. These robots can perform incredibly accurate medical interventions and even complex surgeries, which save lives. There's so many amazing innovations that are becoming mainstream. Self-driving cars, harvesting robots, cleaning robots, space robots, search and rescue robots, security and surveillance robots. The future is here, and AI is at the forefront of all of these innovations.